Welcome to Sri Krishna educational channel. Please like, share and subscribe my channel. So in this video I am going to explain about phenol preparation methods and the properties. So first phenol on the benzene ring, which is consisting the hydroxy group, that is known as phenol. Okay, it is a common name as well as the IUPAC name is also phenol. And in the case of the benzene ring of the phenol, which is having one of the methyl group, so that's IUPAC name is 2-methyl phenol and the common name is orthocresol. The methyl group on the phenol at the third position, it is known as 3-methyl phenol is the IUPAC name and the common name is metacresol. And the methyl group on the benzene ring of the phenol, which is the fourth position, so it's known as 4-methyl phenol is the IUPAC name and the common name is paracresol. When the two hydroxy groups present on the benzene ring, so it's known as benzene 1,3 diol is the IUPAC name and the common name is catechol. Okay, 1 and third position, the hydroxy groups present on the benzene ring, so it's known as benzene 1,3 diol is the IUPAC name, the common name is resorcinol. Whereas the two hydroxy groups present on the first and fourth positions, so its IUPAC name is benzene 1,4 diol and the common name is hydroquinone, or also known as the quinol. Okay, this is also called. On the phenol, 2, 4, 6 the nitro groups are present, so its IUPAC name is 2,4,6 trinitrophenol and the common name is the picric acid is the common name. Okay, phenol, the second carbon has the methyl group and the fifth carbon has chlorine, so that case its IUPAC name is 5-chloro-2-methyl phenol is the IUPAC name. This compound doesn't have the common name. The electron structure of phenol, so in this case there is a 2 sigma bonds are present. Okay, one is between the carbon of benzene ring and the oxygen of hydroxy group, and the other sigma bond that is between the oxygen and the hydrogen, so between that also it has the sigma bonds, only sigma bonds are present. Next the benzene ring consisting the carbon which undergoes the sp2 hybridization and the oxygen of the hydroxy group which undergoes sp3 hybridization. The bond angle between the CO and OH, the bond angle is 109 degrees. This is bond angle is less when comparing with the bond angle of sp3 hybridization, that is due to the repulsion between the lone pair, okay, which is present on the oxygen in the case of the phenol. It's the preparation methods of phenol. So first one is Dawes process. So in this process, okay, when the phenol, that is phenol can be obtained by the chlorobenzene, when the chlorobenzene which is treating with sodium hydroxide at high temperature and high pressure, that is 633 Kelvin and 300 bar pressure, so it forms sodium phenoxide. Sodium phenoxide initially obtained, in addition to that NaCl and H2O. Now the sodium phenoxide which is treating with the hydrochloric acid, so that case we can get the phenol and sodium chloride. Phenol is the main product. So in the case of the Dawes process, so it is a other product also can be possible, okay, that is the phenoxybenzene. So that is this can be obtained, the sodium phenoxide is treating with the chlorobenzene, so that case the sodium phenoxybenzene can be obtained. Now this phenoxybenzene, which for formation of the phenoxybenzene leads to produce the less amount of the phenol. So to avoid this product, we can include some amount of phenoxybenzene in the reaction mixture, so that the reversible reaction can be takes place, so which leads to formation of the more yield of the phenol. This reaction which is mainly carried out based on the Le-Chatelier's principle. Second preparation method, that is Cumene process. So the Cumene process, when the benzene ring which is treating with propene in presence of the phosphoric acid at 523 Kelvin. So initially it formed cumene. It is also known as isopropyl benzene. Now this isopropyl benzene, which is treating with the atmospheric oxygen at the 5% of aqueous sodium carbonate. So that case initially form cumene peroxide. There is a peroxide bond can be obtained. Now this cumene peroxide, which is treating with the acid hydrolysis in the presence of sulfuric acid. So that case it gives the phenol and propanone. It is also known as acetone can be obtained. This is the Cumene process. Third preparation method, phenol, which can be obtained from the sodium benzene sulfonate. Okay, when the benzene which is treating with the fuming sulfuric acid, initially obtained benzene sulfonic acid. Now the benzene sulfonic acid treating with the sodium hydroxide, so it forms sodium benzene sulfonate. Now the sodium benzene sulfonate, which is treating with the strong base like sodium hydroxide at a high temperature 623 Kelvin, so it lose the sodium sulfide and water molecule to form sodium phenoxide. Now the sodium phenoxide treating with the hydrochloric acid, which lose the sodium chloride and gives the phenol. So this is the industrial preparation method for the phenol. Okay, next method, that is phenol, which can be obtained from the diazonium salt. Okay, this is also known as the Sandmeyer reaction. So the Sandmeyer reaction, in this case, the primary aromatic amines which are treating with the nitrous acid, okay, also treating with the sodium nitrate in presence of the hydrochloric acid at a low temperature, that is 273 to 278 Kelvin, which is also considered as 0 to 5 degree Celsius. So initially it forms the diazonium salt. Benzene diazonium salt can be obtained. Now the benzene diazonium chloride, which is treating with the water followed by the heating, it forms the phenol. Phenol can be obtained. So this is known as the Sandmeyer reaction. So this, by the Sandmeyer reaction, the diazonium salt is obtained. When the diazonium salt undergoes hydrolysis, that case also we can get the phenol. These are the preparation methods of phenol. Next, the physical properties of phenol. So in the case of the physical properties, the phenol, which is mainly having the hydroxy group, due to the presence of this hydroxy group, it is undergoes the intermolecular hydrogen bonding. So it's in the liquid form, it is undergoes mainly intermolecular hydrogen bonding. So it can be undergoes the intermolecular hydrogen bonding within the phenol molecules. Within the phenol molecules also it undergoes the intermolecular hydrogen bonding. At the same time, the hydrogen bonding also can be takes place between the water molecule and phenol. So the boiling point and solubility, which is depends on this intermolecular hydrogen bonding. So first one, when we can consider the boiling point, the boiling point of phenol, which is more when comparing with the compounds which are having the similar molecular mass with respect to phenol. So phenol, toluene and fluorobenzene, if we see, phenol molecular mass is 94, toluene molecular mass is 92, and the fluorobenzene molecular mass is 96. The boiling point of phenol, which is 455 Kelvin, the boiling point of toluene is 384 Kelvin, the boiling point of fluorobenzene is 358 Kelvin. So among these, the boiling point of phenol is more because it is having the strong intermolecular hydrogen bonding. But the toluene and fluorobenzene, which is absent. So due to that, the boiling point of phenol, which is more. Okay, next the solubility, if we see, solubility of phenol, which is more when comparing with the solubility of toluene as well as the fluorobenzene. So this is also due to the hydrogen bonding. Phenol, which can be formed the hydrogen bonding with the water molecule. So due to that, it can be soluble in the case of the water, whereas the toluene and the fluorobenzene, which is less soluble. So now if we consider the substituted phenols. So ortho, meta, and para positions, okay, which is consisting the one of the substance like the nitro group. So that case the solubility and the melting point which would become varies. So among these orthonitrophenol, okay, which its melting point is 45 Kelvin, and the metanitrophenol 96 Kelvin, and the paranitrophenol which is 114 Kelvin. So this is due to the paranitrophenol undergoes intermolecular hydrogen bonding. Hydrogen bonding takes place between the two different molecules. So there is a two case the hydrogen bonding can be possible, that is both the nitro group as well as the hydroxy group. Okay, those are present at the, okay, 1 and 4th positions. Okay, there is a two hydrogen bonding is possible, so because of this its melting point is more. Next, the solubility, if we consider solubility of this ortho, meta, and paranitrophenol, the solubility also which is more in the case of the paranitrophenol, so that is due to it can be forms the hydrogen bonding with the water molecule. Okay, both the nitro group as well as the hydroxy group, it can form the intermolecular hydrogen bonding with the water molecule. So due to that solubility is more. But we are metanitrophenol and orthonitrophenol, so which is solubility less. So okay, here the orthonitrophenol which undergoes the intramolecular hydrogen bonding, the hydrogen bonding which can be takes place within the same molecule. So because of this its melting point is less as well as the solubility also which is less. So this is about the preparation methods and the physical properties of the phenol.